Assalamu alaikum everyone. My name is Shayan and I am here with my group member Dhanasha, and we both are student of Fast University Islamabad from Electrical Engineering Department. And as a part of our DLD Digital Logic Design project, we have made a security alarm system which fulfills the fundamental basics of logic gates. So for the overview, Dhanasha will explain it to you.
Assalamu alaikum everyone. So basically our project revolves around a security alarm which is operational using NAND gate. Uh, as you know, the functionality of NAND gate, when any of its input is low, the output is high. So its inputs are connected to the door and LDR sensor. When there is obstacle in any one of those inputs or in both inputs, it will send high output to the buzzer and buzzer will activate. It is applicable to many real-time world applications like in homes, offices, banks, restricted areas like Area 51, etc. So key concept it uses is of NAND gate. As I told you, if any of the input is low, it will trigger the buzzer. Moving on. As we have a view on our circuit components, we have used NAND gate IC7400, and for laser detection, we have used LDRs. It is a variable resistor. Next, for a door, we have used a normal switch. It acts as a path close or path open like a door. For alarm, we have used buzzer, and we have used variety of resistors for voltage stabilization. Next, now circuit simulation will be explained by Shayan.
So coming towards our circuit simulation, you can see that we have designed our project on Proteus. As previously discussed, we have used an NAND gate IC, which whose two inputs are connected to one of the input is connected to the LDR and the other is connected to the switch. The output is connected to the buzzer. There was some technical issue, therefore the sound of buzzer was a very low to be heard on the recording. Therefore, we use a LED bulb which shows the practical demonstration of the buzzer. So considering the truth table of the NAND gate, which states that if any of the input is low, the output is high. For example, if I remove the light from the LDR, which results in a low state input, the output will result in a high state and the LED bulb will glow up. Similarly, if I open the door, the same condition applies to it and the output is high. If both of the conditions are open, means are low, the output is high and the buzzer will keep making sound. And if when the both of the condition are high, input are high, that means light is falling on the LDR and the switch is closed, the output is low and the buzzer will not make any kind of sound. So this was our circuit. The practical implication of the logic design, the logic gate was designed by myself. The inputs connected to the LDR and the one of the input connected to a switch. This was designed by myself. Whereas this chunk in which the capacitor is added was done by Dhanashar. Dhyan, do you like to explain something about it?
Yes, sure. So we have added capacitor basically so that when buzzer one is activated, at that meantime capacitor is charged. So when buzzer one deactivates, the charged capacitor will make buzzer two activate. So basically we have two buzzers. Buzzer two is activated through capacitor. And we have done this so that to continuously make buzzer sound whenever there is an optical reach. This piece of circuit, including capacitor, is attached to buzzer one using relay. So this was a part done by myself. Thank you.
So now the real-time simulation will be shared. Let me show you the practical implementation of my circuit. When the light is falling on the LDR and the switch is on, when the light is falling on the LDR and the switch is on, the output will be 0. But when I remove the light from the LDR, which makes the input A, which is connected to the LDR, to be 0, and the input B, which is connected to the switch, these both results in 1 and 0. But there is a input of a low state as well, therefore which makes the output to be 0, to make the output to be high, which in results make the buzzer to make sound. Now considering that the light is falling on the LDR, but I make the switch to be in a low state 0. This will also makes the output to be high, which makes the buzzer to make sound. Now I'll removing the light from the LDR and making the buzzer making the switch to be in a low state. Both of the input become 0 0, which in result give a output of 1. But when I am falling a light on the LDR and the switch is also in an on state, that's mean this the input A is also 1 and the input B is also 1. The output in results gives a low state, which in results makes the buzzer not to make any sound. So when this implementation shows that if any kind of person tries to breach the security of a house, or he tries to break the light which is falling on the LDR, or he tries to open a door, the conditions will make input of 0 and 1, which in results give a output of 1 high state, which in results make the buzzer to make sound. Thank you. So now coming back towards our presentation, we will discuss about the challenges faced. The challenges that were faced were we were using a ambient light instead of focused laser beam, which in result was giving an input of low state, making the buzzer to make continuous sound, which was false triggering. We resolved this issue by using a focused laser beam on the LDR. The next issue was the buzzer detective issue. We may wanted to make the buzzer to make sound for a constant while, a long period of while, to make the authorities to come to know that any kind of security issues is coming, which was previously described by the Anashar, why we have used such capacitor in our circuit. Now comes this conclusion. The Anashar will conclude it.
So this project basically enhanced our understanding of digital logic with design and the understanding of using basic logic gates in real-time systems. We from this project we came to know the rules of NAND gate and other logic gates as well. So this was the understanding of our course. And secondly, we will understand the importance of how to calibrate the sensors and their sensitivity and how to use them. So this was our observation. For future improvements, we would like to add a GSM module to our system so that if a person is not at home or anywhere, she can receive SMS or call alert through a GSM module. The GSM module will be placed on the circuit and we can expand its range. So we also want to expand its range to multiple zones on windows and rooftop balcony, so it can be expanded and reliable. So this was from our side, and thank you.
Thank you, Allah Hafiz.